Okay, in this video we're going to work on practicing how to use Google Sheets to make figures. And what I would encourage you to do, this is one of those things that you get better at the more you practice. So what I will encourage you to do is follow along with me. You can pause the video when you need to, walk away, express your frustration, whatever, go back to the transcript and review things that are tough. But you are going to, for your assignment this week, you're going to turn in something different. So we're going to be working on the elephant data that we worked on last week and using that to kind of get some experience working with the different graph types in Google Sheets. And then your assignment is to use data that you find to create at least one graph. So, so I'm going to go through some of the techniques, some of the tips and tricks, some of the things that I'm looking for in the thing that in the assignment that you turn in, but this isn't exactly what you're going to turn in. This what I'm doing right here. So I'm going to be doing more than what you need to do, basically. So here I am opening the data sheet from last week. So this hopefully looks familiar to you now. I'm on the cover sheet. Remember the cover sheet functions to collect our notes about what the things that we're doing. So we're going to come back to this here and there and keep track of what we're doing. The other thing that's in this, the other things that are in this file include the original data that we got from the that you downloaded from Blackboard last week, the working copies of those two data sheets, so the data from 66 to 68 and 2005 to 2013, and then remember that we used pivot tables last week to generate the summary statistics for this for these two data sheets. So one thing that I'm going to do is first of all I want to modify this a little bit by limiting the number of decimal places for these numbers that have sort of an unusually large number of decimal places. There's a principle in math and statistics and chemistry of something called significant digits. You don't need to know that here, but the basic idea is that you don't want to imply that you have more precision than you really do. So you want to have an idea. We're going to do sort of the cheap way of doing significant digits and just say we're going to stick with no more than 2 decimal places for any value that's been calculated. So for this value, the way you change that in Google Sheets and actually in Excel is up in this ribbon menu up at the top, you'll see all these different ways to format things. You can actually decrease the decimal places by clicking on this button here. So that's what I'm going to do. I'm going to count down to only 2 decimal places for that number, for this one, for this one, and for that one. So I think we're just in this class, rather than spend too much time talking about significant figures and making sure that we have that exactly right, I'm just going to say as a general rule, 1 or 2 decimal places is the max that you want. Or 1 is fine, 2 is the most. The other thing I want to do is before I work on this data sheet, or before I start making figures, I want to actually copy and paste these tables somewhere else. And this will become clearer why we have to do that later in this video. But a lot of times when you're sorting data, you start to mess up things that you've already, like subtables that you've made. So we're going to copy these tables and put them in a new sheet. Before I do that, I actually want to remind myself that this is 66 to 1968. So I'm going to add this to the heading for this table for both the male and the female test lengths. And I'm going to copy those tables. So I'm doing Control-C here, or you can go over to File and hit, Edit and hit Copy. And I need to create a new sheet. And I'm going to call this sheet, I'm just dragging it to the end here. First I'm going to put that data in before I lose it. But I'm going to call this sheet, and I did that with Control-V, or you can do it by using the edit menu and just hitting paste. So I'm going to rename the sheet by double clicking on the name here, Summary and Figures. Okay, so that's my 66 to 68 data. And now I also want to copy my 2005 to 2013 data. This remember you did this on your own last week. So again, we're going to minimize the number of decimal places, keeping that to 2. So all of these are too long, so I'm just going to change that. Oops, yep, and go down to 2 here, and same here. Actually, what happened here is because I have a few that I selected all of these, because these are already just 1, when I hit the decrease decimal place, it actually made them so they were all even to start with, and then I can start decreasing. So it was a little confusing, I'm sure. I'm also going to make sure I put in the dates here. So this is 2005 to 13, and this is 2005 to 13. Oop. And I'm just going to copy these again. Control C, go to my summary and figures sheet, and put them in here. Okay, so now I have all of the data that we calculated last week, means, medians, ranges, and standard deviations, and so on, for both sheets of data, both time periods of data. So hopefully these numbers look similar to yours. And now we want to illustrate these in graphically. So one of the things that we can do with our data is provide a comparison. And here we may say we want to compare the tusk length of males before and after the Civil War. So remember that 1966 was before the Civil War in Gongarosa in Mozambique, and 2005 to 2013 was after that. So we want to compare. We want to create a figure that's going to compare those values. There's a few ways to do this. I really think that the simplest way for a new user is to start by creating a data table and then using that table to create a figure. So my table is going to have, I'm just going to make a new table here. It's going to be overall the mean tusk length, and I want to compare which way do I want to put this? I think I want to put the years at the top. No, I just want to say, all right, we're going to put males here, and this is going to be 1966 to 1968, and this is going to be 2005 to 2013. So I'm just going to copy that data. So 66 to 68. Control C, Control V, 2005 to 13, Control C, Control V. Okay, so if I just wanted to compare the difference in average lengths of tusk of males between the first period before the Civil War and after the Civil War, I could just select all of this and go up to the menu up here, the insert menu, and choose chart. And this is what comes up, and Google makes choices about how this how it shows up on the figure in the program, and this actually made a choice that I like, right? So it has the 2-year periods, and it's showing me this number, so approximately 98 here, and approximately 85 and a half here. So this is giving me the comparison. It looks like, in general, tusk length is smaller in 2005 and 2013 compared to 66. I'm sorry, in the 2005-13 period compared to 66 to 68. You'll notice a few things, though, that it just makes decisions about how to label things, and we need to change those things. So if you want to change things on the chart, Oh, by the way, so when I click on this, this brings up this side menu. Sometimes if I click somewhere else in the sheet, I lose that menu, and I'm not really sure what to do about it. The way to get it back is to click back on the chart and go to this little kebab menu here. Click on that and say you want to edit the chart, and that'll bring that back right back up. I think maybe if you double click on it, let's see. Yep, if you double click on it, it'll come up too. If you look at this little chart editor here, there's two submenus. One is called Setup, and that's where you determine the chart type, what the series are, which we can talk about in a minute, or we will talk about in a minute, and sort of how it organizes things. You may sometimes find that it's helpful when you make a chart. This did turn out the way I wanted to with the two time periods compared to each other. But if it doesn't turn out, you might want to say, well, what happens if I switch the rows and columns? So that's what happened here, right? So now I have males is the category, and now I've got two different numbers that are the two different time periods. Either one kind of works, but I like this one better. I think these other things you might click on and off on this. You know, row 5 is giving us the header, so sometimes that if you include that, it's going to add this as its own column area, which doesn't make any sense. The labels also, I guess that didn't change much there. So anyway, those are things that you can click on and off and kind of work with to see if you can change so that the figure looks better. The other thing is that you might notice that these axis labels don't really make sense. Actually, this axis over here is the length. That's some measure of length. And this axis here is the time period. So you can change that in the Customize menu. If you go to Customize, you'll see a whole bunch of options here, chart style, etc. If you want to change the name, what's happening on these axis titles, you go to that Chart and Axis Titles area. And you have a choice here for all of the different things that you can label. I actually don't like having a chart title. I think it's hard to get one that makes sense, so I'm going to remove that. Usually what you want is a caption that has more information, so a longer a longer piece of information below it. Let's go back to Chart and Axis Titles here. I want to change the horizontal axis title, which is the one that's flat, and I'm going to change that to time period. So it changed it here. I keep clicking out of it by accident, but remember, I'm just double clicking to get back into it. And now I want to change the vertical axis title from males to mean tusk length. And I want to also put the value that it is, the units that we're measuring. So that's in centimeters. So I'm going to put that in. Okay, so this is a very simple comparison chart that compares the means between these two time periods for males. A lot of times, though, what you want is, in addition to showing the mean, is showing the variability in the population. So how big is the spread? And we get that from the standard deviation. Google Sheets is kind of weird about how it adds the standard deviation. So I'm going to show you how this works, and you will have to do it at some point. It might be something that we work through on an individual basis for all of you, but let me show you how it works. So here I want to add data. I want to add error bars. The error bars are calculated, the error bars that we're going to add are the standard deviation values that we calculated. If you just click on error bars, the program just automatically enters some, usually I think percent is the default, but here it just added a 10% error bar. This doesn't make really any sense. I mean, I'm not sure why you would add a 10% error bar to just show what it looks like 10% above and below the mean, because what we want to know is what's the actual data tell us, which is what is the spread itself, and what is the deviation that we calculated ourselves. And to get that, you don't click standard deviation because, again, it doesn't have that underlying data to calculate from. You have to add a constant. And the constant is going to be the value that we calculated for standard deviation. Now, in Google Sheets, you cannot create two different error bars in the same series. So if I type in the standard deviation that I calculated for 1966 to 1968 as my constant here, so that's 33.63, it adds it, but it adds it to both bars, and I can't change this one by itself. So it's just a weird function of how Google Sheets does things that you have to do this workaround where you change your actually what your series are. You have to create a new series. And I can't really do that without starting over. So I'm just going to quickly run through how you would do that so you can see it. And when you get to a point where you need to do that, you can do it. But if you're going to create for your homework, if you're going to create a figure that has, say, a comparison of means in it, and you're going to add error bars, really all I want you to do, all I want to see is that you added an error bar. But if we want to add specific error bars, let me show you. So this is as far as you have to go. If you want, but you should know how to do it when you're comparing two things that have two different errors. So we're going to get rid of this chart, and we're going to start over. And I'm going to create a chart that just has one of those in it. And then I'm going to add a series to it. And the series I'm going to add, I have to select the data range over here. And it's going to be this number. And now I have these two data sets here. Can I change that series? Let's see. So I'm going to add a series that's this. Oh yeah, this is always confusing to me. So when you add a series, you have to click this little data range picture, this little spreadsheet picture here. You can't just select it. So I'm going to select that. Okay. Yeah, it only wants one column. So it's just like really finicky. So we're going to add another series, and I'm going to do that by selecting that range. Okay, so now I have both. And I want to add to each series, I'm going to add the error bars. So I do that by going to Customize, collecting series, clicking series, clicking not trend line, but error bars. I want that to be constant for, not to all series, but to column 1, which is my 66 to 68. So this constant is going to be 33.63. Oh no, I had those numbers wrong anyway. Is 44.55 here. And then here on this series, I want to have an error bar that's constant, and that's going to be 45.46. Okay, so that is how I would add a different error bar to each one. It's kind of ugly, but it does basically work. Actually, here's an example of where I think switching the rows and columns. Nope. Yeah, it's just such a finicky program, really. So this has done. Anyway, that's how you would do a bar graph and a error bar. And we're not going to worry too much about error bars now. I want you to know how to enter them. I want you to know that what you enter when you enter an error for any given series is the constant value that you generated by calculating standard deviation or whatever other measure of variability that you're using. But that if we want to do that, if you want to do that in an assignment, we'll have to kind of work through it together, I think. Okay, so that's one kind of graph that you can put in. I'm going to get rid of that graph for now. It's a comparison, right? So we're comparing the tusk length of males between the two time periods. We're going to, I will put in my cover sheet, maybe I'll back up a second here. There we go. Okay, so I want to show you a little trick also. So I just went through the back button a bunch of times to get to that figure that I had generated that had the error bars in it. Actually, it has the wrong error bar, so let's make this correction. I'm going to change the error bar in the series to not 33.6, which is the female tusk length, but 44.55. Okay, so that's what this graph should look like. I do want to show you this little trick of if you do what I did, which was just kind of play around and you want to get back to a point where you have something that you wanted to save, you can use the view menu, the file menu, and go to the version history. Now you probably have seen this in Google Docs, right? So anytime you have a page that you want to save, you could name the version and then that will keep it. So let's say male comparison with error bars. So that's going to go, now that's going to go in the version history and I can always go back to it. The other thing that you can do is if you see the version, look at the version history, you can see all the versions. And, you know, say I wanted a version that I had much earlier in the day or much earlier in our period here. All of these are things that, you know, are basically saved every minute. Anytime I made any manipulation, there was a different version saved. So you can always restore an old version from the past, you know, even all the way into last week when I was working on this, right? Okay, so there's a comparison. I'm gonna move this over here. What else do I want to do? I want to talk about I want to show how you would make a figure that illustrates a relationship. And we're going to do that on, let's go to the working copy of 2005 and 2013. So a relationship, remember, is looking at how something changes relative to something else in a data set. So here we might wonder, is there a relationship between, say, the age of the elephant and its tusk length? To do that, or let's say even tusk length and tusk circumference. But say we want to do age and tusk length. So I can work on this page, but I start to kind of change things as I do that. So say I wanted to look at the age versus the tusk length in females in this data set. So I could sort the data set by clicking on this filter arrow. Now I can't remember if we did this last week, so let me show you how I did that. To get a filter view, I clicked on that first row, and then I went to data, and I said I want a filter view, and I could say I want to create a new filter view. So this is my filter view. This means that all of these little upside down triangles are tools that allow you to sort the sheet by the data that's in that row. So there's my filter view, and I want to sort the sheet by sex. So I can click on this down arrow and I can say, all right, sort this A to Z. And it sorts all of the data so that the data that start with F, that are female, are at the beginning, and the data from the males are at the second half. But you can see what happened to these tables over here on the right-hand side is that this all got discombobulated. So we lost a few lines here that ended up down here. That is difficult to repair. So this is why I copied these tables and moved them over here. so that they wouldn't get lost. All right, let's look at our working data again. So now I have the data for the same data that's just sorted by sex. And again, I want to look at the relationship between age and tusk length. So again, I think I want to copy this and move it to another sheet. And I'm going to take these 3 columns, estimated age and tusk length. Actually, I can just click on the tops of those column headings, the letters themselves, and I can hit edit, copy, and then I can paste them over here. So now I have that data for all the females right here. Let me make sure that's all I got. Oh no, I collected all the data for the males and the females by collecting those holes, that whole list. So let me just add the sex here. Actually, no. What I'm going to do is just select the data that I want. So let's select this data, copy it, go here. I'm going to put that in here, and I'm just going to delete these 3 because now I've included all of the data, which includes the males here. And I want to delete those columns. Okay. Okay, so now I have, just for the females, their estimated age, their shoulder height, and their tusk length. Now I want to see if there's a relationship between age and tusk length. So I'm going to just move these data closer. And you can do that a lot of times by selecting it and dragging it, but it's not letting me do that. There we go. So I just, I got the little handle, the hand here, and I pulled it over to where I wanted it. So now estimated age and tusk length are next to each other. So this is an individual, their age and the length of their tusks, and I want to see if there's a relationship between how old a female elephant is and how long her tusks are. So I'm going to select all of that data in those 2 columns, and I'm going to insert, this time, a scatter plot, because that's what shows us a relationship. So this time, Google made the decision to do a line chart, weird decision, but I'm going to say instead I want a scatter plot. So it's one of the options here. You could also look down here to see if they've got it. It's interesting that it looks different here. I don't want that. I don't want 2 different series here. I want them to be plotted against each other. So this actually gave me that option. I don't love that you had to figure that out, but this is a scatter chart and it's showing the relationship between tusk length and estimated age. I think I might want to switch this so that, no, I like this. So as age goes up, what happens with tusk length? I think that's the way to do it. So this is showing a relationship. Often a scatter plot will include something called a trend line. So to get that trend line, you want to customize, go to series, and just like sort of in the same place where you found the error bars for the column chart, you'll find something called a trend line. So now you see the actual line there. So you can see that there's a positive relationship between how old a elephant is and how long a female elephant is and how long her tusks are. So we're going to move that up and just keep that. I do want to, before I forget, I want to make sure that I'm making some notes on the cover sheet. So on the cover sheet, we calculated graph. So the bar graph shows, compares male tusk length from before the Civil War. That's 1966 to 1968 to after, 2005 to 2013. Error bars are not accurate. The error is the standard deviation calculated for 1966-68 for both bars. This is an issue of designing a graph in Google Sheets. Okay, so the scatter plot compares, looks at a relationship between age and tusk length in females in the 2005 to 2013 sample. Trend line is inserted. Okay, so just keeping track of what sorts of things I'm doing here. So we've shown relationship, we've shown how you illustrate relationship, we've shown how you illustrate a comparison. Now we want to look at a composition, and one way to do composition is to do a pie chart. So this might be, say we want to look at the composition of males versus females in 1966. So we're going to say 1966 to 68, count of males, I guess we start with females and males, and we're going to do, I'm just going to type these in, females is 230 and males is 206. So I just got these from the sample size from the count. All right, so let's see what happens when we insert a figure here. Sometimes it's just a surprise. So I don't want a column chart, I want a pie chart here, and this is showing me the frequency, proportion, percentage of males versus females in 1966 to 68. Let's just say sex ratio of males and females 1966 to 1968. So that's one way to show a comparison of the composition of a population, for instance. But say we want to compare 66 to 68 to 2005 to 2013. Let's see how we can do that. So 1966 to 68 here, and 2005 to 13 here. Get rid of that. And we'll call this, we'll say, well, we need the numbers here. 93 goes there, and 68 goes here. So what might we do here? If we select all of these, we can get a chart that stacks. And here we want the two, so I just asked for a stacked column chart. So that was one of the options down here. I could have also done it as this kind of bar. I kind of like it better this way just because it feels a little more obvious about the change in the population. And we're looking at the relative contribution of females and males in both of those time periods. So this is giving us the raw numbers. You can see there was a huge drop in population in these two time periods, and also kind of a loss of males relative to females. You can see that more directly if you put it in percentage terms. this change in the percentage of males and females. What I did here was change it from just a regular standard bar chart, which is giving us the raw numbers, to a percentage one, which is allowing us to compare the overall percentage. So it's a different comparison, and you want to keep track of that. I think what I want to do is do the standard. So we'll move this graph down here, and we'll say sex ratio and population size in 2000 before and after the Civil War. Okay, so now we have a figure that shows composition, or two figures that show composition. And if you want to compare composition from one time period to another, you really want to use a stacked bar chart instead of two pie graphs, because it's sort of hard to eyeball two pie graphs. Let's make sure we put that on our cover sheet, what we did here. All right, pie graph compares percentage of the population of males versus females in 1966 to 68, stacked bar graph compares sex ratio and population size of elephants in 1966 to 68 versus 2005 to 2013. Okay. The last kind of figure you can do is a distribution figure. So we're going to do that. I guess we'll do that with tusk length. We've got it right here. And that is the histogram. And we did this a little bit sort of briefly last week, so hopefully it's familiar. But let me just select this data. And again, I'm going to insert a chart, and went right away to histogram of tusk length. Again, I want to look at maybe changing axis labels. So I don't necessarily want a title this time, but I want to add a vertical axis title, and we would call this number of individuals. So the number of individuals in these different categories of tusk length in the female population. So actually maybe I do want to keep a title in here, just because I'm not necessarily going to use this figure for anything, and it's the easiest way to capture that information. So for chart title, I'm just going to say for the female population in 2005 to 2013. Okay, so the last graph I've added here, go back to my cover sheet, is a distribution, which is typically a histogram, illustrates the distribution of tusk lengths in females in 2005 to 2013. Okay, so now I have a cover sheet that has all the information about the figures I have. I have a bunch of figures that show the different ways that you can compare things, or different ways that you can analyze data. You can do comparisons, you can look for relationships, you can look for a distribution, something that might tell you something interesting about the distribution of about how the population has changed. You might be able to get that from the distribution. You might get information about how a population has changed by looking at composition over time or in 2 different time periods. So these are all sorts of analyses that you may be able to do for your data analysis project, and this is how you would generate those figures and make them look pretty. Now, just real brief, I guess I did kind of mention this before, but you can do all sorts of things when you click on different parts of the figure. You can change colors. Oh, that's a terrible combination. Not better, but anyway, you get the point. You can change colors of your bar graphs. You can make fonts bigger or smaller. Maybe I want to go even bigger there, and so on. So all of this is going to help you when you're presenting your data. You can change the legend font size. So all sorts of things that will help things be easier to read or interpret. Okay, so what I'm looking for in your homework is for you to find a piece of data, to find a data source, and make a graph. And hopefully what you're doing is, as you're thinking about what graphs you can generate, is that you're picking data that will be useful for the analysis that you would like to do, and you're doing some preliminary graph generation. This doesn't have to be a graph that you end up using in your final project. The idea is for you to continue to think about what your project is, practice with the graph making capabilities of Google Sheets, and then show me what you've done to that point. All right, hope this was helpful, and I'm looking forward to seeing what you come up with.